open close design principle. The motivation is that software is always changing. In fact, all design principles are in fact addressing the software changeability. And change should be able to be made with minimum impact. The actual definition of open close design principle is that the classes should be open for extension for adding new functionality, but it is closed for modification. What that means is that design or coding should be done in a way to allow adding new functionality as new classes, while without modifying any existing code. The benefit, of course, is that the existing code, assuming it has been tested before, does not need to be changed. So it shouldn't have any impact to the existing code. So that is open close design principle. I would say this is probably the most important design principle among all design principles that we are covering today. Okay, so let's take a look at the lab. So open close principle. So let's see, what is, yeah, here we go. Open close principle. So in this case, we have a payment scheme class. So payment scheme class is basically, in this case, it's just having a payment scheme name, and it has a getter and setter method. And then we have a customer class, which have a pay method. Okay, and now this is the case that we are not using open close design principle. So the idea here, the bad part is that whenever a new payment scheme needs to be supported, we need to change this code because we have if and else logic. So we have a pay method, it received the payment scheme, and then we check whether payment scheme is cash or credit card. And depending on which payment scheme is used, we have to use a pay method of a particular class. So in this case, we are using cash payment scheme, in this case credit card payment scheme. So if we need to support like a new payment scheme such as a PayPal, then we have to actually change this if and else logic or switch logic, and that's a bad thing. What we want to do is we want to add new payment scheme like a PayPal payment scheme without forcing the change of existing code. Okay, so let's see how we can refactor the code to the after. So what we have done is we are going to abstract payment scheme. So we are going to have an abstraction. This abstraction is abstract class, which has a pay method. And we have a payment scheme is injected through a setter method in this case. Okay. Now, if you take a look at the customer class, so this is actually where the things are refactored. Okay, so let me just see the code. Let's see the code, and I'm going to explain this good part. So basically, it's receiving this payment abstraction object, and then it's going to use this pay method. Okay. So good part is open close principle is used. In this example, this code does not need to be changed even if we are adding new payment scheme. So if you are adding PayPal payment scheme, this code does not need to be changed. In fact, because it's using abstraction, it doesn't really know what concrete payment scheme is being injected. Okay. Okay, so let's, so it also talk about dependency inversion, but we'll talk about that one later. Okay, and the cash and the credit card, they actually the same class as before. Okay, so cash and pay. So in this case, let's try to add. So let's actually try to run this code. So basically pay with cash. If you take a look at the client code, so let's actually take a look at this client code as well. So in this case, the payment scheme can be set during runtime. In this example, we simulate the runtime setting of the payment scheme via command line argument. So the payment scheme could be selected during runtime, and that's again good part of this implementation. So here we are simulating by actually having the payment scheme to be received as a command line argument. Okay, so here let's say we have a string com jpassion.dp cache, and that's the default. And if command line argument actually passed a different one, like a com.jpassion.com dp credit card, and that will be used as a payment scheme name. And then basically what we are doing here is we are creating that class. So we are using class full name and new instance. This is another way that you're creating Java object. Instead of using new keyword, you could actually have the name of the class, a full class path, and then you can use full name and then new instance. It basically create payment scheme abstraction object, in this case using this string. So this is just a simulation of runtime selection of a payment scheme. I mean, you could actually select a runtime payment scheme, or you can create this object through some factory class and stuff like that. The key point is that it could be set there in runtime. And then we create the custom object, and we are injecting payment scheme. Okay. All right. So in this case, if we can certainly choose a different payment scheme through the command line argument or factory class. Okay. Now I'm going to demonstrate. I'm going to demonstrate adding PayPal payment scheme, and again that should actually follow open close principle, meaning it should not change existing code. Okay, so let's actually add a PayPal. So I'm going to create a new and class, and I'm going to say PayPal, and I'm going to just simulate the behavior. So I'm going to just copy this code, and this one should be PayPal, and I'm going to say PayPal, and this one should be with PayPal or something like that. And let's save the change. Let's see. We have to actually extend. We have to extend this abstraction, right? So we have to extend this guy. So we are going to extend this PayPal scheme. Okay. Now I can actually support this PayPal scheme without making any changes in other class. I don't have to make any changes in this abstraction. I don't have to make a change in customer code. So this is a good part. Customer is receiving this PayPal, the payment scheme abstraction. The abstraction is using abstraction, but the actual payment scheme could be the cash or credit card, or it could be PayPal. So I don't have to change any code. And in the client side, I could actually pass the name of the payment scheme as a string. For the sake of this exercise, I'm going to just change it right here. So I'm going to say dp PayPal, like this, and say change, and I should be able to run. And you can say the pay with PayPal is actually being printed. So if you compare before and after, in this case the customer code need to be changed because it's not using any concrete, it's not using open close principle. So in fact, whenever you see if and else, that is bad code smell. You need to think about whether that is absolutely necessary or not. Okay, so in this case, if I need to support PayPal, I have to change this customer code, and that customer code is the existing code, probably have been tested before. Now I have to do retesting, and I have to figure out whether the change in customer has an impact in other code that actually uses this existing code. So it has a huge implication if the application is relatively big size. In open close principle, in after code, I don't have to change any other code. Basically, in order to support new functionality, I just add a new class. Okay. Okay, so I'm gonna let you do this exercise. Again, I'm gonna actually have you guys to change code from before and after, and make sure you also add PayPal payment scheme as well as I did. Okay, so I'll give you guys 10 minutes to do this exercise.